This example is to solve the triangle when we know side A is 16 kilometers, side C is 10 kilometers, and angle B is 40 degrees. So we start by using the law of cosines to find the length of side B. Using that relationship, we have b squared is equal to a squared plus c squared minus 2ac times cosine b. Substituting our known values, we get b squared is equal to 16 squared plus 10 squared minus 2 times 16 times 10 times cosine of 40 degrees. Now you could substitute all of that into your calculator and find an answer. And if we do that, we get the result that b squared is equal to 110.866. So therefore b is plus or minus the square root of that value, but obviously since we're talking about the length of a triangle we can't have the negative, so b would be approximately 10.53 kilometers. Now we need to find the measure of angles A and C. To do that, we can use the law of sines. You certainly could use the law of cosines again. Using the law of sines, we would need to use one of the relationships which involves sine B over B, and then we could choose to solve for either angle A or angle C first. So let's solve for angle A. If we solve for angle A, we would find sine A over A is equal to sine B over B. Substituting gives us sine A over 16 is equal to sine of 40 degrees over 10.53. Then we can multiply both sides by 16 to get sine A is 16 times sine of 40 degrees divided by 10.53. And after we enter that on the calculator, we get sine A is equal to 0.9767. Now, I need to back up and talk to you for just a minute about using the law of sines in this particular case. Notice that we only have one known angle, so we're in the case of side-side angle, which is our ambiguous case. And so we need to think about that when we're trying to find the value of our angle. So our angle A, we do know the angle A is going to be the longest or largest angle because it's opposite the longest side of the triangle. But we need to compute that. Remember that there are two values whose sine is positive 0.9767, and if you use the inverse function, you're going to get the one that's in the first quadrant, which is 77.61 degrees, and in the second quadrant we would get that A could also be, if we subtract this value from 180, 102.39 degrees. Now, once we know angle A, we already know angle B, so to compute angle C, we're just going to subtract the value of angle A and the value of angle B from 180 to determine that. So we have two cases that we have to consider. We have to look at what if A is 77.61 degrees. Then that would make our angle C what? Well, C in that case would be 180 minus 40 minus 77.61. And if we compute that, we would get C is equal to 62.39 degrees. Now if A is 102.39 degrees, then angle C would be 180 minus 40 minus a 102.39, which would give us that C is 37.62 degrees. Well, which one is it? They both seem logical, right? But we have to look at our angles and our sides and recall that the longest side has the largest angle opposite it. The smallest side should have the smallest angle opposite it. So since C is the smallest side, angle C needs to be the smallest angle. So therefore, we would have to have that C is 37.62 degrees. So this case where A is 77.61 does not make sense in our triangle. So we found the values that we would need. C is 37.62 degrees and A is the 102.39 degrees.